All right, so I'll go ahead and just reiterate what I said. So my name is Kenny Coleman. I'm an open source technical product manager here at VMware, focusing a lot on Kubernetes. Somebody had asked about my t-shirt earlier. I'm part of the Kubernetes release team as well. That's how you get fun t-shirts like this, is being part of that open source community. So let's go ahead, we'll dive in and really show you about how to build your first Kubernetes cluster on top of vSphere. And this is going to be using an open source tool called Kubeadm. Now, the reason why I'm talking about this and why I'm showing this is because typically when we start learning about Kubernetes, you start learning about kubectl, you learn about deployments, you learn about replica sets, you learn about how to deploy applications, but you kind of forgot that first step of, oh, how do we actually build our first Kubernetes cluster, right? Like for an infrastructure type of crowd, that's typically the thing and that's where the background I come from, is that's what I want to know as well. And so today, if you're not familiar, or you probably are familiar now, you've all been hearing about Kubernetes, you've heard about the new Tanzu announcement, and so we're going to be focused around Kubernetes and looking at, really this is a focus on orchestration at the end of the day, and that's really what Kubernetes is delivering. So as with any infrastructure engineer, we always want to start looking and diving into the documentation to figure out, okay, let's build this. And there's going to be a lot of things that you might not understand when you start looking through this, because there's one common theme that's going to be coming up consistently when you're trying to build your own Kubernetes cluster, and that's choices. Because if you start looking around, you start looking at all the different options that are out there, things that are already available that are, can be spun up easily on a cloud, to local machine solutions, turnkey productized solutions, everything like that, you would spend probably a solid 2 years trying to evaluate every single thing that's up here. And not only that, is new things are continually being added every single week within inside of this ecosystem. So it's an ever-going evolution of figuring out exactly how do we operate this, how do we want to be able to manage it as well. And so really a lot of these tools are starting to figure out, okay, we're not just going to be a glorified Kubernetes installer. We've got to figure out how do we build more function and features and everything else around it. And this is because everybody has kind of started relying on Kubeadm or Kubeadm, or however else you want to say it. There's a lot of different terminologies that are out there. And so Kubeadm has really become the de facto community standard on how do you build conformant Kubernetes clusters. So when I talked about that last slide and you look at all those different features and all those different options, a lot of them are using Kubeadm underneath the covers now. And so this is really going to be looking at a little bit, again, underneath the covers, more of those details to see exactly what's happening and how is it actually being created inside of here. So again, this is something that the community has really come around with. If you are new to Kubernetes, or if you've been around for a while, there is a repo out there called Kubernetes the Hard Way. That was something that was created by Kelsey Hightower. And if you go and you look into it, it goes from everything of actually having to create your own SSL certificates, creating your own services within inside the Linux boxes and everything like that. It's tough, right? And what Kubeadm tries to do is simplify all that, tries to automate the hell out of it as much as it can. So it's a higher level tool that can be used here. And so when we start down this path, we have to figure out, okay, well, as we all know, we want to start with a virtual machine. But if you're starting this from the very beginning, you have to figure out, let's start over. What's my distro? What have I standardized on? What are my security practices? Am I cool using something like Ubuntu or CentOS, or do I want to use something that is more centralized or focused for Kubernetes like Rancher? There's another one that just came out recently called Talos. Next is actually looking at making your distro configurable. So if you want to use this as a particular template or an AMI, what are those dependencies that you're going to be installing inside of this particular VM, and how far do you want to take it? And if you're looking at following guides, that's really what we all do. For anybody that used to be a developer in here, everybody knows that 90% of code just comes from stack and paste or copy and paste from Stack Overflow, right? So we're usually looking at blogs that figure out how do we build these things. And if you start looking through and you're saying like, oh, okay, I found a blog on this is the type of OS that I want to use. This is the dependencies I need. It was created for Kubernetes 1.11. Odds are it's completely outdated and you've got to go and relearn exactly how do we do this now, because we're the last stable release is now 1.15.3. So it's a quarter release cadence that's coming out. So it's a continual progression of how do you keep up with all these releases as well. And when we start talking about the installation process, how far do we take it inside of those particular virtual machines as well? Do you install Docker? Do you install the Kubernetes components? Do you script it? Do you utilize something like Ansible outside of it? Like, what is going to be your way that you try to build this on your own? And the way that I'm also talking about here is really the open source way of being able to build this, right? This is not a productized version or anything like this. This is a completely open source, so you're going to get your hands dirty and actually get to know a product. This is how you're going to start doing it. Now, the other thing that is inside of here is when we talk about sizing requirements. This is something that within the entire ecosystem, nobody really has a good gauge on how do you size a Kubernetes worker node. Well, because we don't know exactly how many containers we're going to run in each one. We don't know what kind of applications we're going to run. We don't know what the requirements or utilizations are. So today, it's really best guess. And so figuring out exactly how do we scale our worker nodes to make sure that they can be scaled easily and quickly and added into a cluster is going to be a key component when figuring out exactly how do we add more resources as needed and as on demand. So now we want to start figuring out, okay, let's start installing Kubernetes. All right, well, there's more research to do. As I mentioned, you can start looking at all the different types of underlying components that can be pushed and pulled and kind of interchanged with inside of Kubernetes. So sure, everybody here has probably heard of Docker. There was a project out there called Rocket at one time that was supported underneath the Kubernetes. There's other CRI compatible runtimes if you're not a Docker fan. So there's other things that you want to try to do, and maybe there's lessons learned that you need to figure out too. Anybody here ran Docker in production? That's not a lot of hands, right? Now, there's a lot of things that most people need to understand is what are some of those lessons learned that you need to figure out? What about log rotation, right? To make sure that your client doesn't blow up on you. Are you okay with the overlay FS support driver or driver for storage and everything like that? So there's a lot of things that if you even haven't ran Docker in production that you can start learning about as you start heading down this path as well. And then you have to figure out, how do we architecturally want to build this? Do we want a single master? Do we want multi-master? Do we want to make sure that our etcd servers within inside of our cluster are stacked on the masters, or we want to separate them out and manage them differently? So architecturally, there's even more things to figure out when you want to build this on your own. And if you are going down that multi-master path, you've got things like load balancers, DNS, certificate sharings, and even more that you have to build into this. So this is also what we're going to talk about where Kubeadm is going to be helping you along the way of actually making this a lot easier too. So networking, if you want to even start going down the path of networking, there's more choices, right? This common theme is going to continually come up. So up on top of here, you've got 8, if I can count 8, maybe 7, different networking choices that are available. So you go to Kubernetes.com, you go look through the docs, you figure out, okay, I'm ready to start installing Kubernetes, and you start following through. And these are the options that are available to you that are open source, ready to go, single one-liners, you can get up and running. However, do you know the difference between Calico and Flannel and Kubeadm or Romana and Weave, right? These are things that you have to go and research to figure out what is going to be your interpod networking construct of how you're actually going to have Kubernetes components talk to each other underneath, right? So from an open source standpoint, there's a lot of research that you still need to be able to do to figure that out. And not only that, when you're utilizing Kubeadm, there is an initialization phase that has to take place. And that before you run Kubeadm, you've got to make sure that there are some prerequisites that are taken care of for each types of these networking choices that are out there too. Now, when you start looking at the open source ecosystem and what tools are going to be available for you as an administrator from a networking standpoint, hate to say it, there's really not a whole lot. When you start going into each one of these is trying to figure out, okay, how do we troubleshoot interpod networking, like just things that happen? I don't really know. I don't have that answer for you, right? Because each one of these, a lot of them have other commercial tools that are built on top of them, or they've got UIs that they want you to be able to look at. So there's a lot more research has to be done to figure out how do you operationalize just from a networking perspective of inside Kubernetes too. And the other thing is scale. There are multiple papers that have been published about each one of these in regards of not only just scale of how many pods can each one be able to handle, but as well as latency and throughput of what they can do for their applications too. So you've got to figure out which one works for you as well. So we're not ready to install yet because we still have to figure out storage, right? Persistent storage is a key component of actually what made Kubernetes really, and Docker for itself, actually become a main staple product or project, because it's not just for web servers, it's not just for stateless workloads, but now we can start looking at utilizing stateful workloads now. And it's a continually evolving process and project within inside of Kubernetes, because everything today is still within tree or ships as part of the core Kubernetes code. And here in the next few releases, everything will be moving out of tree into what's called CSI, or the container storage interface. And now when you get to there, you're going to have more things or new things that have to be configured of actually how do you get your vSphere provider to talk to Kubernetes from more of a plugin rather than utilizing the embedded code there as well. So one of the things that we're going to start looking at here is this blog that we're going to kind of follow through. So this was done by Miles Gray at blah.cloud, and it kind of just gives you an idea of really what the steps that he went through to figure this out. And just to give you some background here, this took a few teams within inside of VMware a few weeks to almost 2 months to actually figure out exactly how do we get our vSphere cloud provider, continue working with Kubeadm, as well as automating it and everything else like that too. So with inside of his instructions, he talks about utilizing the Ubuntu cloud image for cloning, and that is reliant on DHCP. So when I went to my environment to do this, I don't have DHCP, so therefore I couldn't do it. So everything that I do is based off static IPs and with CentOS. So there's ways that you got to figure out what works for your environment. The second one is actually setting up Kubernetes for the cloud provider using Kubeadm. And the last one is actually going to be creating and deploying volumes, creating a storage class. All right, so let's go ahead. We'll hit up a demo real quick, because I think that's what we're all here to do, is see some of us pound some code on the keys. So I'm going to go ahead and I'm going to kick this off real quick. And I'm going to start installing the master. I'm going to show you exactly what these are all going to be doing here. So let me get these kicked off, let the installation start. Okay, so this is what's happening. So with inside our Kubeadm master, can anybody see this okay? Well enough? I know people over here can't, so I apologize. Can you in the front row see it? That's all that matters, right? No, I'm just kidding. So what we're going to be doing is this is the steps that I had to go through to figure out how do I automate the ability to start putting in all the dependencies that are needed by Kubernetes to actually just put this on a blank or just a blank template of a CentOS host. I will try to blow that up a little bit though. So first is turning off swap. It's just part of the Kubernetes prerequisites of actually having to do that. You have to actually turn off swap and then actually remove it from the Fs tab as well. I'm a terrible admin. I don't really care about figuring out what ports need to be open, so I just said, screw it, I'll just disable the firewall completely. So don't do that in production, just showing you here. Next is installing Docker. These are the components that are required. The other thing is when you start looking at the individual Kubernetes versions, not all Kubernetes versions are compatible with all Docker versions. So you have to figure out when you start looking into it, you got to find that compatibility matrix of what's going to work there. The other thing that I'm installing here is called version lock. Version lock is going to play an important role here in a minute, and I'll kind of tell you why. The other thing is looking at some of the best practices for running Docker in production is actually having some log rotation here, utilizing overlay 2 as my storage driver 2. From here, going ahead and now Docker installation is done. But what I'm doing is I'm putting a version lock on this particular Docker version. I'm doing the same thing down when I get down a little bit lower for my kubelet and my Kubernetes versions. And this is because when I go to my machine and I try to be a good sysadmin and I do a yum update to just install security updates, I don't want Docker and I don't want Kubernetes updating, right? I want that to stay in a lock. So you can utilize version lock as your ability to make sure that nothing happens from there when you do want to go ahead and run some updates on there. Next, I'm putting in my Kubernetes repo. Now I'm installing my kubelet, I'm installing Kubeadm and kubectl. Kubelet is really what's going to be doing a lot of the work in the background here. Kubeadm is going to be creating our conformant clusters. Kubectl is my CLI or my command line into the cluster in itself. Now that I've got my kube stuff done, I'm going to go ahead and start the kubelet, and I am also putting a version lock on those 3 as well. Next, since I am going to be running Flannel here, this is part of what I call the prerequisite of what the networking construct actually needs. So this is what Flannel calls out as actually has to be done before you start running Kubeadm. Next, I'm going to create my vSphere configuration file. With inside of here, I am yet another terrible admin. I just gave complete administrator privileges to my vCenter here, so don't do that. Next is actually putting in and tying and mapping in my vSphere components into the individual workspace here. So you can see exactly what my vCenter server is. You also have to specify a default data store. So this is going to be using vSAN on the back end as well. And just to give you an idea, there was one thing that I actually found very interesting actually going through this process. Let me probably have to log back in here, is that when I was trying to figure out exactly how do I map up my vCenter components to really what Kubeadm is trying to look inside of here, it says you need to put in the folder path for your resource pool. Well, I don't have a resource pool, right? What does that look like? It took me about a week of just like completely getting it wrong over and over and over again until I realized it's just cluster A/resources. Right? And so that means I don't have an individual resource pool underneath of it. So the other thing that is in here that's kind of unique is that I have to specify a folder of where my master and my worker nodes are actually living. And you can see I just put in the folder called Kubernetes. Next, just public network, just a port group. And then from there, I'm creating my configuration file for Kubeadm. So within here, I'm just giving a bootstrap token. I'm also specifying the type of Kubernetes version that I'm running here. I tested this on the plane on the way here, so let's hope nothing breaks. Is that I used to demo this with 1.14.1, but I realized that it's kind of outdated now, so I just put in 1.15.3. So we'll make sure that everything's working there. It's specifying the vSphere configuration file. And this pod subnet right here is another requirement that's required by Flannel during this pre-configuration process. So when you go through and you choose what each one of those 7 different, when you start evaluating, each one is going to have some sort of unique pod networking subnet that you need there as well. And then from there, I'm pulling some images. You can see I'm going to start initializing the cluster, initializing the master, and then from there I am making sure that I can start utilizing kubeconfig. On the worker side, it's a lot of the same stuff, disabling swap, disabling the firewall, go on and so forth. The only thing I'm really not doing is doing a lot of things that require from the master for Kubeadm. So it's just a lot of the same stuff, just a little bit more minified, I guess, if you will. So we can come here, we can see that worker's about ready. This worker's ready. This master has been done as well. You can see exactly everything that happened into the script. Here is where you see Kubeadm start taking over, where it's actually going to start pulling those images, generating our certificates that are necessary for the master and the workers to all talk to one another, as well as getting the kubeconfig file ready and then bringing the control plane up, and then also making our bootstrap token. Now, I'm also going to speed this up a little bit by copying and pasting a lot of stuff here. So, one of the things that is really rad about a lot of the networking constructs is that I said that I needed to have Flannel installed. There we go, Flannel's installed, right? It's a one-liner of actually getting it up and running. So it's really easy in being able to do that. We can see exactly what pods are running. I don't think they'll all be up yet, but we can see that core DNS will be up here just in a few seconds. And then once that's up, we should be able to get going. So now we're up and running there. So what we want to do is we want to take our configuration file here, dump it out. I'm going to dump it over to my other host, or my worker node. I'm going to dump it over to my other worker node as well. Now I do this and I say kubectl get nodes. We can see right now all we have is the master that's available to us. So we can go now to our worker node over here. We can clear that. We can see that we put in that discovery YAML file. And now we're going to join our worker. We're going to do the same exact thing over here. So what it's doing is it's actually talking to the master. It's now sharing those certificates back and forth so they can go and they can talk to one another over TLS as well. And by the way, for anybody that has really deep questions on Kubeadm, we have Tim over here. So Tim was one of the main authors behind Kubeadm with the pink Kubernetes logo over there. So Tim, say hi to the crowd. So make sure if you have really tough questions, ask him, not me. All right, so now we've got that worker, we can come over here, and there we go. We just built our first Kubernetes cluster, right? Woo! I know, little tough to build up to that, right? But that's what it was to actually build our first Kubernetes cluster. So a little bit of scripting involved of being able to do it, but again, we're not really done yet, right? That's just the cluster. For me to actually utilize it, I'd have to add in a storage class to actually utilize some of the persistent mechanisms and stuff like that in it. So let me go ahead and we'll show you just a few more things here, some slides, and then we'll start wrapping this up. So we figured out actually how to build the cluster, but there's so much more that needs to be done. You know, you've got things that you've got to figure out. Actually, how do you operationalize this thing? So for everything from logging and monitoring, device and security management, dependency management, and being able to do this over multiple cycles. As I mentioned, Kubernetes is released once per quarter, a new version of it. Typically, there's usually a lag that most people will say, like, I'll wait another quarter, or I'll just put in patch releases. I'm never going to do the 1.x, I'll wait till 1.x.1 to actually start implementing that sort of stuff. So there's a lot of things that you need to figure out exactly how do we operationalize this and how do we make this available for us. Now the one thing is figuring out upgrades. Kubeadm does upgrades for you, right? So it's a one tool that you can utilize to actually upgrade your clusters from one version to the next. They do a fantastic job of writing the documentation that what needs to be done from one version to the next. There is not a lot of stuff that says, like, can I skip versions, right? Everything is going to be sequential orders, and that's the way that typically that the upgrade process works. And the other thing that I kind of forgot to mention as we start looking at this is automated repeatability. Like, why would we want to not just create one big, massive Kubernetes cluster? Well, we found that most customers actually would rather create multiple smaller clusters that are dedicated either per BU or per tenant or per application or anything like that, rather than creating like one massive cluster. You know, it's a little bit different. I know sometimes in the vSphere world, there might be a lot of people that have, you know, 32 node host clusters or something like that with massive scalability because you're just packing everything in there. However, when you're looking at the application development, application development aspect of this and not just owning infrastructure, it's a little bit different of actually where do you want these Kubernetes clusters to live and how do you want to orchestrate all your applications as well. So I already talked about regression testing, and the next thing is support. I just showed you how to do that. When I had problems, I didn't have anybody to call, right? Everything's all open source. So you go and you try to look at either blogs and articles, you go to GitHub repos, you get on Slack channels, and you start talking to the maintainers that build this stuff, and that's how you get support in here as well. So just to kind of give you an idea of what was also announced this morning is looking at the Tanzu product portfolio that is coming from VMware of actually how you build, run, and manage all your Kubernetes services underneath this as well. Now, on the Kubeadm side, here's just a little bit of roadmap things that are happening. So 1.15 was released. This is currently in beta, but for the longest time with Kubeadm, you can only have one single master. There wasn't a way to actually have a multi-master setup. And this is another thing we start thinking about architecture is, do I need a multi-master setup in a vSphere environment? Depends on what your needs are, right? And how highly available do you want this, because you're already packing in HA and DRS underneath the covers within inside of vSphere. So it depends on how complicated do you want your setup to be and really what is going to work well for your environment. The other thing is that I know a lot of people are looking into Windows support within inside of their environment. When you start looking at how do we add in Windows nodes as workers into your Kubernetes clusters. Kubeadm is going to be working on this for alpha and 1.16. I was hitting on the issue owners this morning, so we'll see if it makes it. But again, this is one thing that I know a lot of people are looking forward to, is adding in Windows nodes as workers as part of that Kubernetes cluster, so you can start running .NET Kubernetes applications too. You're going to start looking at more advanced Kubeadm configurations that can match more Kubernetes parameters as well as customize here in the next few versions too. So if you want to get started, you want to start learning more and doing this, go and check out Kubernetes.academy. This is something that is being announced this week that is coming from VMware as part of CNABU, or the Cloud Native Apps Business Unit. So this is a way that you can start learning about Kubernetes. There's online tutorials, there's videos that just show you exactly how you get started and how you start really running on top of vSphere as well. The other thing is, I'd mentioned go and check out Miles's blog over at blah.cloud. The gist of all my scripts are located beneath there. I should probably put a bit.ly link up for that because I doubt anybody's gonna have time to write that down. But the steps that I utilize to install Kubernetes on CentOS, utilizing Kubeadm with vSphere is on my GitHub gist there too. If you are interested in learning about what enterprise PKS can do, there is the hands-on lab that's available for you there too. And with inside there, you can there's a few labs that show you exactly how you get started utilizing kubectl and creating your first cluster, just saying PKS create, and then the cluster is up and working. With that, I finished just in time. I've got 9 seconds left. So make sure you please, if you like this, fill out your survey. Hopefully I got the first session out of here, and hopefully you enjoy the rest of the code sessions that are here to come. So thank you all very much and have a great VMworld.